Hello guys, so today we are here to solve our daily LeetCode challenge for the day. The challenge is largest combination with bitwise and greater than 0. Okay, so this problem is about doing the bitwise and. Okay, and see, as a general property of bitwise and, see, let me just show one example to you that as a general property of bitwise and, if we have some number, okay, and one, so see, all int numbers are actually 32 bits, okay, and let's say at any bit position, if the number is set, if the bit is set, and we are doing that set bit and 1, the number will always be, the result will always be 1. Okay, it will be 1. Okay, and same if we do at that set bit position and we do 1, let's say 0, we do AND with 0, then the once the bit is set to 0, it will always be 0. It cannot be reset back to 1. So, and also that 0 and 1 is always 0, and 0 and 0 is also 0. So this is one of the basic things about it. And since this result is given as int array, so also I would like to mention that all integers in languages like Java are actually 32 bits of zeros and ones. Okay, so this is one of the basic things about it which we have to keep in mind, okay, while solving this problem. And now let's go back to the problem statement. What this problem statement is saying, see, it is telling a largest combination with bitwise and greater than 0. Okay, so largest combination, see, this is this is kind of giving you a false hint. Whenever you hear the word combination, the mind goes to backtracking. Okay, and but see, the mind goes to backtracking, but the constraints here, the candidate's length, this is 10 to the power 5, and no way backtracking will be able to tackle this large sample size. I mean to say, backtracking will not be able to handle this large instance size. 10 to the power 5 is 10, after 10 there are 5 zeros, so that is not possible for us to handle. So how are we going to solve this? So in order to solve this, what I think that we should be thinking about some other things. So let's dig deep into the problem statement and think what we need to think about it. So it's saying bitwise and, so it's defining this line is defining what does it mean by bitwise and. So bitwise and of an array nums is bitwise and of all integers in nums, bitwise and of all integers in nums. Okay, and bitwise, so it's, suppose this is given as, okay, suppose this is given as suppose this is given as this array is given as nums 1 5 3, then the bitwise and is equal to 1 and 5 and 3 and is equal to 1. So this is the bitwise and how are we going to solve this? So and for this individual array, this single array, the single element array, the bitwise and is 7 only. Okay, and it is telling that since you are given an array of positive integers called candidates is the input array, and it is a integer, positive integers. Okay, evaluate the bitwise and of every combination of numbers. Each number in candidate may only be used once in each combination. Each candidate in number may only be used once in each combination. So return the size of the largest combination of candidates with the bitwise and greater than 0. So what is the maximum set whose bitwise and of all elements is greater than maximum array, maximum size array whose bitwise and is greater than 0. So we don't have to maximize the total value of bitwise and, we just have to tell what is the largest array. Okay, and as we know, at any bit position, if we have 0, and then once 0 comes into AND, then it cannot be set back to 1. So all we need to do that we have to individually check the bits. Okay, individually check the bits and find out if at any bit position, you know, all the elements of the array are set, then we will not be getting 0 at all, and we can return safely that answer. So we don't have to do combination of each and every element and then find out, because that will be totally hectic. We have to just go through each bit, and then we have to figure out whether the answer is correct or not. So in order to go to each bit, what we'll do, that we'll create a mask, and this mask will be starting from 0, I is less than 31, okay, plus plus I will do, and then what we will do for, okay, int j is equal to 0, and we have to traverse through the length of the candidates. So candidates is equal to n, and int n is equal to candidates dot length, okay, and int count is equal to 0, like this, okay. And then what we will do here, j is equal to 0, j less than n, okay, plus plus j, and then what we will do, that we will do if candidates, no, not if, just directly we'll do candidates is the input array, candidates of I, okay, and we'll do count plus is equal to candidates of I. It will go to that okay. So this will create the mask, and 1, okay. So it will check whether that particular bit is set for each one or not, okay. And after this value of count, what we will do, so we will initialize our count 0 here itself, and count is equal to 0, let it be like this, count is equal to 0, okay. And then we can do we'll do one max count, that is also equal to 0, okay. If count is greater than max count, when we have max count is equal to count, like this, and then we'll be returning count, okay. So let's run this and check what is the answer. Candidates of j, not I, sorry. Return max count, we have to return, correct. Perfect. So this is one way. We can even make it even faster by putting one check over here. If count plus n is the total number of elements, n minus j minus 1 is less than max count, okay, then we can just simply break out of this, okay, and let's run this. Perfect. So this is one way to solve this problem. With this, happy coding, thanks a lot, best wishes.